called to the cloud. So
Screen share, desktop 1. All right. Can you all see that?
Yep.
Awesome, cool. So yeah, Kotlin. This talk is a talk that I gave last week at Go To Chicago, and I'm kind of doing a slightly shorter version here, but it'll have all the same content. Going over Kotlin, some of the language features, what it's about, what it is, and then also how it can be used on multiple different platforms so that you can use it pretty much anywhere that you're developing. I'm sure there's some edge cases out there that I don't know about. So yeah, there's Kotlin. It's a language. According to the Kotlin Lang website, it's a statically typed programming language for modern multi-platform applications. When it says modern multi-platform applications, this means that it's for the JVM, Android, the browser, JavaScript native, so lots of different places. It was developed by JetBrains, so it was developed by developers for developers to take care of some of the pain points that you have when working with Java. Like I said, it's available for the Java virtual machine, for Android, JavaScript, and for native. They made it so that it's concise, which we'll see in some of the examples. It's safe, interoperable, and it's also tool-friendly, especially if you're using the JetBrains IDEs. They have a lot of tools built in from the start. As far as like the language in specific, its typing is strong, static, inferred, and null safe. And we'll see that in some of the examples. It favors immutability in a lot of different ways. I'm also going to show some of the smart casting that it has, as well as higher order functions and some of the boilerplate reduction that it provides. So starting with the typing. Kotlin is statically typed and similar to Java, but where it differs is that it's also inferred. So instead of saying string name and then put the string, I have Victoria here, you can just say name equals Victoria. And then notice here in the Java example, we have final. When you use val in Kotlin, that makes it a read-only property. So that's why I have the final in Java to make it equivalent. If we wanted this to be a read-write property, we would use var. Nullability is also built into the type system in Kotlin. So right in the type, we know if something can be null and the compiler forces us to check for it. We notate that something is nullable by adding a question mark to the end of the type. So here we have the type ice cream, and then we have a question mark to say that it's nullable. So the value ice cream, that can be either null or have something of the type ice cream. And there's the question mark. So since ice cream is nullable, the compiler forces us to check for null before we can call something on it. So here we're trying to call ice cream.flavor, and we're getting a compiler error because we have not checked to see if ice cream is null before we're using it. Now, one way we could check for null is to wrap it in an if not null block, but it would be kind of messy to have these all over the place. So Kotlin has some nice language features to help us handle these nulls. One of them is the safe call operator. That is this question mark after ice cream before .flavor. That does pretty much the exact same thing as that if not null block on the previous slide. If ice cream is not null, it's going to call that flavor on it and return that. If ice cream is null, then it's going to return null. If you're looking for errors, I'm not sure why you would be. I'm sure there's some cases out there, but if you really, really like errors and handling those, then this might be the operator for you. What this does is, this is the 2 exclamation points before dot flavor. Here, if ice cream is null, it's going to throw an error, a null pointer error. And then if it's not null, it'll call the flavor and return that as usual. So that's the double bang operator, or 2 exclamation points. I don't know how it's spoken, but it's that. You can combine the safe call operator with a couple other things. One is the else operator. That's this question mark colon here. If you turn your head sideways, you might recognize a familiar face. What this does is it allows you to provide an optional value if something is null. So this first part, the ice cream safe call operator flavor, does the same as we described it before. If ice cream is not null, it will return the flavor. However, here, if ice cream is null, it's going to combine with the else operator, return the value that we have at the end. So if ice cream is null, it's going to return a chocolate chip. We can also use the safe call operator with higher order functions to create null safe scoping. So here we have ice cream with the safe call operator, that question mark before the dot let. And then we're calling let on it, which is a higher order function. We are passing in a lambda, that's what's in those curly braces. It's assigning that value of the ice cream to the not null ice cream variable. Then we have an arrow, and we're calling a function on it. We're calling that flavor. Kind of a lot just to call that flavor on it, but this is really great when you have a block of things that is dependent on the ice cream not being null. Now this does look a bit verbose. There is a ways to simplify this in Kotlin. Just wanted to start off with the verbose version so that we could make sure we understood all of the parts. We don't need to name that variable not null ice cream. If we don't give it that name, it will default to a variable named it. So then we can just call it dot flavor. If a lambda is the last parameter in a function call, you can put it outside the parentheses, and since here it's the only parameter, we can omit the parentheses. And then one other option is to use a function reference. So that was all about the typing. Now we're going to look at a couple things about how Kotlin defaults to immutability. So here we have a val conference, and I'm using the string go to Chicago here because that's where I presented it. And like I said before, val makes it a read-only property. So on the second line, where we're trying to reassign a string to it, we get a compiler error. We can change that by making it a var that makes it a read-write property. A lot of times when you write in Kotlin, most people get into the habit of starting out with val and only using var when they need it. And I feel like that helps you be much more intentional about what things should be mutable or not. Another way that Kotlin defaults to immutability is with lists. To create a list of things, you can use a list of function. And if you use list of, it's going to create a read-only list. So once you create the list, you cannot modify what contents are in it. So you can't remove the 2 out of this list of 1, 2, 3, or you can't add 4 it. If you want to be able to add and remove the items in a list, you have to specifically say you want a mutable list of something. And again, that helps you be really intentional about what things should be allowed to change. You can keep in mind with this that if the objects themselves are mutable, so say you have like a class person and you can change their username in it, then that class will still be mutable, but you can't add or remove that person class. Okay, so with the immutability and typing, we can get smart casting. So let's say we have a class conference and it inherits from an event. We can check to see if an event is a conference, and then within that block in Java, you'd have to explicitly cast it to a conference. In Kotlin, you can, after you check to see if it's a conference, it uses smart casting to automatically cast it for you, and then from then on within that block, you can treat it as a conference because of that smart casting. It's pretty handy and removes that extra boilerplate. And now for this section of even more boilerplate reduction. One way that Kotlin helps reduce boilerplate is with the way it handles classes. So starting with this simple class, this is a cupcake class. We just have the keyword class, the name of the class, and then the properties. We have a val, so read-only property flavor, that's a string, and then we have a var, so mutable property icing with a nullable string. So we can have icing or no ice cream on this icing on this cupcake. Just to understand how much we can get from this, because this is nice and concise and just the information that we need. Let's look at what the equivalent would be in Java. And it would be all this, and I took away the bodies of the functions so that it could fit on the slide. They're pretty self-explanatory for the most part. We have our fields for flavor and icing. So because we use the val, we have a final string flavor, and then we don't have the icing as final. They're both private. They both have the nullable and non-null annotations. So that matches with what we said. We also have a getter for the flavor and a getter and setter for the icing. This matches up with what we said for the val and the var. We also have a constructor that takes in the flavor and the icing, and it assigns those 2 properties or those 2 fields. And that's super awesome. It removes a lot of that boilerplate for us that we'd probably have to write. And even if we're not writing it, because our editors will often do that for us now, we don't have to read it. We can get even more by making it a data class. And we do that just by adding the keyword data. By doing that, we get everything that we had before plus these new things. So we have the things from the other slide. Then we have component 1 and component 2. This returns the flavor and the icing respectively. You don't usually call these just on their own. It's used by the language framework for destructuring class declarations, which is cool, but I'm not going to go in too deep about that right now. You also get a copy function, a toString, a hash code, and an equals. So there's that much less we have to write and read. One thing that I've been enjoying lately is sealed classes. Now, to solve the problem of wanting to have a set number of states of things, you could use an enum. So here we're having a 3 different states for the response of fetching something. let's say getting the conference, and it can result in a success or an error or in progress. And this is great, and this restrictiveness is perfect in some cases. By using sealed class, you can get a little bit more power while still having it being restricted. Sealed classes, a sealed class is an abstract class with a finite number of classes extending it. So here we have our sealed class get conference state, and then we have our success, our error, and our in progress. The first thing that you get because of this is with the enum, you get one instance of each of the values. In here, you can potentially have multiple instances of success or multiple instances of error. You can also have different kinds of additional information on them. So here for the success state, we can also include the result of the conference. And for the error state, we can have a error message string. And then for the in progress, there's no other information that we need for this, so that has no extra information. It also gives you more flexibility with the type of classes. So we have success as just a normal class, error as a data class, and then in progress as an object, which you can think of as a singleton. These are especially powerful when using when statements. So with this when statement, because we know that we have only the 3 types of state within that sealed class, so success, error, and in progress, we don't need to have an else branch because we can be sure that this is exhaustive. So we know that if it's success, we can say show the conference. If it's error, show the error. Or in progress, we can show loading. We're doing something similar to this in the Android apps, and I found it really cool. I've been enjoying using it and learning how to take advantage of it. That's the only features I'm going to go over today. This is a great talk that was also at GoTo that covers even more of the features. And then I cover more of the features and compare them to the equivalent Java and looking at the bytecode if you want to look at that layer of it. For the rest of the talk, I want to go over where you can use Kotlin. So like I said before, you can use it on the JVM, Android, JavaScript, native, which means you can use it for mobile, both Android and iOS, the server, browsers, different views. There's lots of places that you can build it in as far as like IDEs. There's IntelliJ and Android Studio, which is what I'm most familiar with. Eclipse, you can use as standalone compilers. So with all of this, you can kind of Kotlin all of the things. If you're not ready to set it up in your environment, you can always try it out right in the browser at try.kotlinlang.org. It's fun to just type stuff out in there and see what happens. It's great for understanding some of the language features. You can do like the Kotlin cones in there. So it's cool. It's fun. So starting with the Java virtual machine. With this, you can use it on the server, Android, Java applications, really anywhere that can run the JVM. With writing Kotlin for the Java virtual machine, it's completely interoperable with Java. So that means that you can continue to use the same Java libraries that you're familiar with and like. Kotlin tends to be more flexible and concise than Java. And I haven't personally worked with Scala, but I've heard that it has much less feature bloat. It's more geared towards developers, while Scala is both academic and for developers, just kind of making those a little different. If you're starting with a brand new project in IntelliJ, they make it super easy. You just pick Java and then Kotlin JVM and follow the rest of the steps in the startup wizard. Then once you have the project set up, we can create a new Kotlin file in the source directory. This is just a standard hello world main function. So we have function main, and we have our args string array, and we're just printing a line. Then you can click run in IntelliJ, and it will run it and print out this line. Very simple, but it's a really small short startup to get going with it. You can also compile Kotlin for the JVM using Gradle. This is great if you already have a Java project and you want to add Kotlin to it. So you can have both Kotlin and Java in your project. And you can call Java from Kotlin, Kotlin from Java pretty easily. To do this, you can set up the Gradle Kotlin plugin and apply it, and then add these dependencies to your Gradle. Alternatively, if you're in IntelliJ, you can go to Tools, Kotlin, Configure Kotlin in Project, and it will automatically do all of the things for you. And then if you're using Eclipse, you can download the plugin from the marketplace, and then do file new Kotlin project. The rest is pretty much the same as in IntelliJ. You create a new Kotlin file. This is the same Hello World program, and then you can run it as Kotlin application. Then you can always use the command line as well. You can install the command line compiler from the website for your machine. We have our main function in a hello.kt. You run the Kotlin C compiler on it, and then you use Java to run the jar file. Just so that you can be aware, this is the equivalent Java class. Notice that in the Kotlin example, we just have a top-level function, function main. In Java, it's wrapping it in a public final class that's the same name as the Kotlin file. So hello.kt will become a class hello.kt. Then we have our public static final void main string args. What's a little bit different about the inside of this function that you might not have expected is this intrinsics check parameter is not null. Because it's interacting with Java, it cannot completely rely on the null safety that Kotlin provides in the typing because Java does not enforce this null safety. So here it has an additional check to see if the parameter is null or not before it keeps going. If the parameter is null when it should not be, it will throw an error and point to that specific argument. In IntelliJ, there's a built-in way to convert Java files to Kotlin. There's 3 ways to get there, using the File Explorer, a keyboard shortcut, or just searching for the action. And it does a pretty good job of this. One of the biggest things to watch out for with this is the double bang operator. A lot of times when you're converting to Kotlin, you're trying to eliminate those null pointer exceptions, and those double bang operators are where those are going to come from. So spotting those and deciding what to do with them is a big step in making your code safer by using Kotlin. Other ways to compile for JVM is using Ant, Maven, Griffin. There's examples of how to do these on the Kotlin website. I'm an Android developer, so of course I have to note Android in here. Like I said before, it's similar to Java. We like using it. It's more flexible and concise than Java. We can still interact with the Java libraries, and it's because Android Studio is built on IntelliJ. We have a lot of great support in Android Studio, and the fact that Google is supporting it for Android now as well is super exciting, and we get even more support, which is great. When creating a new project, it's just as easy. Just check a box, include Kotlin support, and then if you're using Gradle, it's similar to add it to an existing project as the Gradle example I showed before. And I'm assuming it's similar for other build tools. I've only done it with Gradle. You can also compile Kotlin for JavaScript. So you can use it in the browser and for any JavaScript framework. This is an option for writing type-safe JavaScript, so an alternative to TypeScript. With this, again, you can interact with all of the existing JavaScript libraries. Similar in IntelliJ, it's really easy to create a new project. You pick Kotlin and then Kotlin.js. This is creating that same Hello World file. And then as an easy way to run it, we're just creating an index.html that includes these script tags. It has one for the standard library as well as the sample app that we wrote. You have to build the application in order to generate the JavaScript. And then if you open that index.html in the browser, look on the console, you'll see that hello world that it ran, it printed out. You can also compile for JavaScript using the command line. This can be particularly helpful when creating libraries. You have to download the Kotlin CJS compiler, and then you just use that to compile the JavaScript, and then it'll give you sample library.js, and then sample library.meta.js. It's called that because that's what was named in when we ran it in that command line. Other options for compiling for JavaScript are Gradle and Maven. Again, there's instructions for those online. A quick note that you can also use Kotlin to build views. If you're making HTML views, you can use the Kotlin X HTML library to interact with and build HTML views. And then there is Ongo for Android. With this, you can use Kotlin for the logic of what to display in your views while you're building them. So just a quick peek at what Kotlin X looks like. Here we're creating a document with a div that contains a paragraph with a string with the text inside. So it's a DSL for creating those views in those documents. And within all of this, you can include the same logic as you would other Kotlin programs. The one last place that you can compile Kotlin for is native. There's compilers available for Mac OS, Linux, and Windows. It uses LLVM. And with this, you also get the same interoperability. You can interact with C libraries for this. So to do this, you have to download the compiler for your operating system. This is using the command line. Creating that same hello world function, use the compiler to compile it, and then we can run it as an executable. Other options that you have is if you're using the C-line IDE, and then there's also an option for Gradle. Looking at all of these, you might be thinking, can I use this across platforms and share the code? And the answer is yes. It's technically experimental right now, but you definitely can. With this, you can share logic across platforms while also keeping native sections for any like framework components. So if you have a Java version that's using, or a Java section that's using Java frameworks, you can still do that while having JavaScript stuff in another place, and then having some common code that's used by both of them. with that, there's the common module with code that's shared across platforms. Then there's platform-specific modules for each other platform that you're including, let's say JavaScript and Java. And then you have a sort of interface for the common code to call platform-specific implementations of things. To get started in IntelliJ, it's the same thing as we saw before. We just picked the multi-platform option. What happens with this is this gives us a couple different modules. We have the common module that has all of the shared Kotlin code. We have a JVM module. We have a JavaScript module. Essentially, different modules for different platforms. And then when it's built, the JVM module will compile onto class files. The JavaScript module will compile onto JVS, or to JS. And then the common module will compile down to both the class and JavaScript for them both to use. How we define that interface between the two, if there's code in the platform-specific modules, is in the common module, if we expect something to be in the platform modules, we use the keyword expect. So here we're saying in the common module that in the platform modules, we expect there to be a dog implementation with a function bark. So that in our main function here, we can create a dog, we're gonna name him Spot, and he's gonna bark. Then in the platform module, we're gonna have the actual implementation using the keyword actual with the actual function that just is printing stuff out in this case. But with this, you can use the platform-specific libraries. So say we had to use a date library and we want to use the Java date library in Java and the JavaScript date library in JavaScript. This is how we could create an interface that the common module could call a date class. If you want to get started learning and trying things out, I found that the Kotlin Lang docs are stellar, and even just reading through them is amazing. Just trying things out without having to set up an environment is fun too. Go to try Kotlin Lang. There's also different exercises you can do there just to get some familiarity with different Kotlin language features. Kotlin.link has links to pretty much every single thing you might want to find on Kotlin, whether you want it on Android, JVM, native, if you want blog posts or tutorials or videos or books or anything else. It's a pretty extensive collection of different links to different things. I have the resources from my talk on my GitHub. Then there's also a conference that you can go to. There's the Kotlin Slack community, and you can just talk to me or Joe or lots of people. Yeah, that is what I have. We can discuss for a bit.
Thanks, Victoria. That's cool.
It's awesome.
Thanks. No, I stopped this shit. That one. So yeah, that's what I have. Intro to Kotlin. It's fun. I like it.
One question, did you ever try to use Kotlin anywhere else than Android, or just like for the experimentation?
Not anything like more than Hello World.
Okay. It looks interesting.
Yeah, but I know for the last Kotlin Conf, they do have the multi-platform they have like an open source repository that had the Android app, the iOS app, the server, and the web app. All in Kotlin using shared code.
Wow.
So that's a public repository that you can poke around in.
So like an iOS app written, like everything written in Kotlin?
I think maybe everything but the views.
Oh, okay. Yeah, that makes sense. That's cool.
Mm-hmm. So I've only looked at it a little bit, but I thought it was like really cool that all of that was in Kotlin. And then they were like able to use that as examples in their talks at Kotlin Come.
Yeah, definitely.
Mhm.
Let's talk to the OS team and get it.
Right? Yeah. None of them are here.
Kotlin, I'll just go ahead and make the dashboard in Kotlin now. I'll just do everything in Kotlin. That was really cool.
Thanks. Yeah, thanks for coming.
Is it would you say, like, I mean, I have very little experience even with like Android and Java. Is it like something that, would you start a new Android project today with Kotlin, or is it something that is still like sort of early stages? And sorry, I changed a poopy diaper halfway between this, so I don't know if I can.
No, that's fine. Yeah, I'd definitely start a new Android project with Kotlin. That's what we did with Reply and the team app. And now Google is supporting Kotlin for Android. So even more and more people are using Kotlin, and their documentation is slowly starting to have Kotlin examples as well. So yeah, I'd definitely start off with Kotlin is what I'm doing.
That's sweet.
Mm-hmm. Yeah.
Cool. I'll stop the recording here if no one else has any questions.
That's all I have.